I welcome all the participants for the International Diploma of Soil Mechanics, and it's my great privilege to be a part of Center Geotechnical International team. And today, here we are going to showcase our main objective of Diploma in Soil Mechanics, what we are going to study in 8 modules. So I will be explaining in detail why this course is very important, why faculty, students should learn this course, and how it will be helpful for their everyday activity when they are performing the civil engineering projects. So this picture clearly shows this is the soil, this is the report we are keeping. But I'm sure that once you complete this course, you are able to identify the type of soil exactly, and also you can able to note down systematically different types of soil. Soil means what, why, where to use, how to use, when to use. So you will understand everything step by step. Meantime, I will be making you some familiar case studies. I will be showing you, and I will be interacting with you by giving some problems, practical problems, so you can understand and you can try to correlate what is happening in the real scenario and why this subject is very relevant to the current scenario. You will enjoy it, I'm sure that. So before going to my presentation, I would like to tell about myself introduction. Myself, Dr. Naveen.B.P, currently working as Associate Professor and Head at Amity University, Haryana. I did my bachelor's in civil engineering from University Visvesvaraya College Engineering, Bangalore, M.Tech in geotechnical engineering, National Institute of Technology, Karnataka, and MS, Ph.D. and postdoc in geotechnical engineering from Indian Institute of Science, India's premier institution, world sixth rank. This institution, I completed all my premier degrees in this premier institutions. So coming to my credential research, you can see my citation is 650, H index is 11, I10 index is 11. Till now, I published a CI and Scopus journal paper, all Q1, Q2 journals of about 28. And also, I published articles in reputed national and international conference. Total, it is 34. And I have written one book on geotechnical and 6 book chapters. And also, I have filed 8 patents and 5 research proposals, all with respect to geotechnical engineering only. And I already guided one student, and 3 students are working under me. And also, I am guiding total 5 foreign students. One student have completed his project under me, and another 3 is progress. Shortly, they will be submitting their thesis. And MTech 11 is completed, 6 is under progress, and BTech 7 they already completed. Coming to my awards, I received 11 prestigious awards, and also I delivered 55 plus, more than 55 keynote address India and other globe. So I used to deliver in various occasions on the environmental day, soil day. So always my talk will be mainly targeted for the students so they can inspire what is happening in the current world. So they will try to take that project as their thesis dissertation so they can concentrate. In additional to that, I am a visiting faculty in Sense and NLD institution. It is in Bhutan, and it is a research center where I used to teach solid waste management subject also for PhD students. And I'm an editorial board member for 21 journals in my specialization, and also reviewer for 24, like a prestigious Elsewhere, Springer, Tyler and Francis. And I also organize one national and international conference and seminar. I organize 14, workshop 4, consultancy 4. This all foreign related. Sitting in India, I used to handle the foreign projects also. So you can see that I'm specialized in especially on foundation. So I used to travel globally and I try to understand the what is happening and try to address the solution with economical and simplest way, suggesting suitable foundations. And till now, I have 5 years of complete academic experience, research 6 years experience, and industry 6 years experience. Total, I have 16 years of experience. As I already told you, see, this is my academic qualification, University Vishweshwara College of Engineering, where I did my bachelor's, then master's, National Institute of Karnataka, then another master's in research. This is in a premier institution I told, Indian Institute of Science, and PhD and postdoc all are from same institution. Coming to my research related, why my works are so unique. Why my work is so unique and why I'm connected with the student. The reason is always I try to take practical problems and try to solve that in a realistic way. See, this is the problem I have taken of metro foundation and try to validate with numerical modeling like a Plaxis as well as FLAG. So this is the output. You can see how finite element software validating with finite volume method. And next problem I'm going to address is this is slope stability. This is, you know, that because of heavy rain, landslides are happening. To understand, so what I did, I have modeled and tried to understand this by using Plaxis Studio. In addition to that, I used to develop the new equipment for the consolidation purpose. See, this is the with the foreign collaboration, I developed the equipment. And this is the model. This is the ground level. You can see that each layer, how the soil property behaving and how this load is transferring from top to bottom. So you can visualize it. Now coming to this diploma in soil mechanics, why you want to study this course? What is the benefit? The objective goes like this. This diploma is structured for you to develop a knowledge and understanding of soil and its engineering properties are very important for the engineers working at the site to make in civil engineering structure safe and serviceability. We can see this person is trying to drill the soil and try to identify bedrock or whether you got a safe starter, hard starter. So how you will identify? So this knowledge plays a vital role. Soil mechanics is the only thing you can visualize what is happening below the ground level. And also under different loading conditions, the soil is subjected to various stresses and problems like waterlogging, liquefaction of soil, seepage through soil, and settlement. So because now continuous rain is happening, what will happen? So earthquake happen. So soil will behave differently. So in that case, how you will design the foundation and how it will behave. So you should understand everything. So all these things at diploma level, students are expected to study about this aspect of soil to develop their understanding in order to apply their knowledge in construction industry. It means that whatever we are trying to learn in the classroom, that always it will be helpful to correlate in the your field problem. And also this course will focus on first on the soil mechanics. Actually, what do you mean by soil mechanics? Soil mechanics is the basics of for all geotechnical application. One must learn the basic principle of geotechnical engineering through soil mechanics, and it is in a core course for civil engineers in every college, university across the globe. See, that's why you already accept that we are able to construct the infrastructure in every, whether it is in a developing country or a developed country. When you are doing this, you should understand the soil mechanics. So that is the basic and that is the fundamental for the civil engineer. Every aspect of soil mechanics, starting from origin of soil to shear strength of soil, will be covered with detail under this section. So we try to touch all the modules. So we should get the familiar what is happening, how to address everything. Now coming to this software applications. In this course, we are introducing one software that is called Plaxis. That Plaxis is a finite element software that has been developed specially for analysis of deformation, stability, and flow in geotechnical engineering. The input procedure enables the enhance the output facility, providing the detailed presentation of computational result. So, based on the soil report, whatever we are getting, we are putting that values in the software and try to visualize how it will behave layer wise, or how the soil will take the load at every layer or not. You can able to feel that when you practice this software. So what I used to do, I will be doing this Plaxis Studio version 8 software. This I will be applying in the module 6. The reason I'm using version 8 is because it is freely available for all the candidates. So we can use it very higher version, but what happens, it will be difficult to purchase. This software is very costly and this software is from the Netherlands. So to make you more familiarized, so what I did, I used to use lower version. So at least you will get the feel of the subject. Now coming to the syllabus, in unit 1, I will be going to cover the main salient points. Like first, the title is Origin of Soil. Origin means how soil has came. You will be understanding the history, list of the structure where soil is used as a construction material, soil formation in the geological cycle, state the type of failure due to the soil in civil structure, general characteristics of different types of soil, overview of different types of soil, entire globe, maybe in India or any other country, how it is differ, why each soil will be differ in different places. In that case, how to understand and how to identify the suitable foundation that we are trying to learn. In second module, what we are going to do is, this is index property and interrelationship. Here we have a three-phase diagram. First, we are trying to understand three constituents of soil, and also sketch showing the three phase like the soil, air, water. All the phase diagram we are trying to understand. With the understanding, we are trying to derive the equations like properties like density, field density, dry density, saturated density, void ratio, porosity, specific gravity, degree of saturation, moisture content, density index. So this all empirical things will be derived. And coming to this, derive the following relationship. Once we understand all this definition, then we are deriving all the why we want to do this, why it is essential. The reason is, once you know the dens density sorry, once you know the density value, suppose if you want to design the foundation, in soil report some data are missing. So what you will do? You will back calculate. How you will back calculate? By taking this empirical relationship. Then you can able to get that values. And these values will be helping for the design of foundations. Next module, we are trying to understand the classification. On the first slide only, I told you soil is a normal terminology, but when you're going a detailed understanding, you can see this picture. Different types of soils are there. Different types of soil with the different colors, continuous. You can see this. It clearly shows that if you are having this much variety, will you call everything as a soil? See, yes, layman can tell, but geotechnical engineer person never say like this. He will be very particular to tell maybe a sand, silt, clay, gravel, anything. So you will be analyzing and you will be trying to understand. So in this module, first what you will do, classification of soil, basic criteria of classification, like soil, it has three main categories: scale of the classification on the basis of grain size, and mechanical analysis of soil, that is difference between the coarse grained and fine grained soil. And also sorry, in you will be doing the grain size analysis, and you will be generating the curve. You try to identify type of curve, whether it is in a well graded, poorly graded, and also you identify the different types of coefficients. And also we try to identify the consistency, Atterberg limit. See, that is the consistent liquid limit, plastic limit, shrinkage limit. In fourth module, we try to understand very practical and everyday activity. You will be seeing this type of rollers. There you will try to understand strength properties, like first, like density, field density, as well as laboratory density. See, this is the laboratory density. You will do the field density also, roller. In this module, you will be understanding the soil compaction, moisture density relationship, standard Proctor test, compaction of sandy soil, that is nothing but cohesionless soil, and field compaction. Next thing, next module, you will try to understand the permeability. What do you mean by permeability? Why you want to do this test? Why? You know that now suppose rain is coming, once rain is coming, where it will go? It will come. The rain will fall on the soil only. The soil will absorb the water. So each soil will have a different property. Some soil will take water more. Some soil won't take water. It will take and it will leave it. Like example, if I want to give, sorry, if I want, sorry, suppose if I want to give a practical example like sand, the nature of sand, it will take water and it will leave immediately. It won't have the capacity to storage. But similarly, the same water is incorporated in clay soil, but clay can drink more water, it can take, but the coming out from the clay water is very minimum. It will take long time. So to understand this behavior, what we used to do, we used to do different types of testing. Constantate, this is constantate, and falling gate. This is the beauty of this thing. So based on this experiment, you can decide whether your soil is a type of material, drainage material or not. Now coming to main thing is consolidation. Why you want to learn the consolidation? Why you want to learn the consolidation? To understand the settlement, how much load soil can take. So that part you will be trying to understand. Compressibility coefficient, pressure void ratio relationship, Terzaghi theory for one-dimensional, odometer test, effect of pressure range, settlement of footing, estimation of immediate settlement, estimation of consolidation settlement, field versus log peaker, pre-consolidation. See, this all you will be trying to understand, and you will design the foundation such a way that it should not be settled in any scenario. That's why today, if your structure is very strong, because the engineer have understood all this property and he has designed the foundation very systematically. Next, first, foremost important is shear strength. You're trying to check the strength of the soil. How? By conducting various tests like direct shear, triaxial, uniconfined, main shear, and also the Skimpton pore pressure parameter. This is for the to check water pressure. See, this is the equipment, triaxial equipment you are trying to understand. In last module, what you will do, students should understand all the module and they should work on some projects as per their interest, any mode. So I will be guiding them. They should write the thesis, and they must always try to work on the practical related problems. So you will get a lot of appreciation after completing this project, even if you go for the interviews or if you are planning to do PhD, master. So this type of work, always it will be highly appreciated by anyone. Before going to in detail, let me have that let me have the detailed discussion about origins of soil, what I'm going to discuss. So firstly, I will be showing why, what, all this. See, you can see these pictures. He is a civil engineer. As we already know, civil engineer will have a lot of specialization like soil mechanics, foundation, environmental structures, so many things. The first and foremost thing to construct any building or any project, always the foundation should be strong. For that, soil should be always play a vital role. You must understand it. Okay. See, this is In this module, we are trying to understand geotechnical engineering encompasses a vast field with diverse engineering application. The two broad areas under this jurisdiction are soil mechanics and foundation. See, this is the one word what we used to call geotechnical. In the geotechnical, you have further classification is called soil mechanics and foundation engineering. And the soil mechanics covers the theoretical aspect of different types of soils that a geotechnical engineer has to work with. And foundation engineering deals with the application of theoretical knowledge to solve real life design problems. Okay. And most of these problems involved in the design and construction of foundation of various types of structures, including the buildings, retaining walls, sheet piles, so many things. In some situations, the geotechnical engineer has to deal with artificial improvement of weak soils using a compaction technique, reloading, sand drying, geotextical, so on. See, this method is called as a ground improvement technique. It means that if soil, when you are constructing a foundation, you encounter with some black cotton soil or some weak soil, what you will do, you will be improving that. How? By stabilizing or by doing some dynamic compaction or by using some textiles. See, this is next. Here you will be trying to understand in this module why you want to do the soil boring, why you want to learn different stratification. When you are doing the boring, you will see the different types of layers of soils. You can see color. Unlike other construction materials such as concrete, masonry, steel, or timber, soils are problematic. In situ property soil vary widely from place to place. You can see this. See here, what is the soil property you are getting? Here you won't get. You can see here it is very look like a soft, but when you are going deeper and deeper, the properties are completely different. So even at the given site, the significant variation in soil properties are encountered both in vertical as well as lateral directions. That's why soil is always undulation material. It won't retain same in entire structure. This is the reason always we used to do boring at every frequent interval and try to understand the nature of the soil and design the foundation accordingly. For that, you should know the knowledge. Now coming to this, all soil, who is the parent for the soil? If you are asking, see, we have parents. Similarly, soil will also have the parent. How it is derived? So it is derived from the rock. The properties of soils are primarily derived from those of the parent rock, through several other factors also have strong influence. Soil is a particulate material, which means that the soil mass consists of accumulation of individual particles that are bonded together by mechanical or attractive. You can see this, how it is. When you hold in hand, the soil will be completely have a stiff attracting, because all this mechanism, I will be teaching you how, why. And also in soil, the voids exist between the particle and the voids may be filled with a liquid. Voids exist between the particle, may be filled with a liquid or gas. That's why we are trying to understand by three-phase diagram. So we try to understand and try to understand in detail by doing compaction, consolidation, how to remove the voids. Coming to this origin of soil, first we have to understand civil engineering point of view. Soil may be defined as a conglomeration of small solid particles generated from the disintegration of rocks. As I already told, for the soil, the parent is rock only. The size of the particle present in the soil deposit is not uniform, but exhibit considerable variation through within the narrow range. It may be from 0.0022 to about 5 mm. The particles are arranged randomly. The space between the larger particles are occupied by the smaller particles, while the space that are still left are occupied by the particles that are even smaller. So you are trying to analyze that in phase diagram. Okay, in spite of such packing of particles, the soil still contains substantial white space, which may be occupied either by the air or water, or sometimes it both. Due to this reason, soil is referred as a three-phase diagram. And coming to the outermost layer of the earth crust, reaching to the depth of approximately 20 kilometers below the ground surface, is made of soil and rock. Of this, the top 50 meters or so is really interest to the geotechnical engineer, since the effect of construction of new structure rarely reach the deeper. That's why here you are able to get the difference between the shallow foundation and deep foundation. When you want to go for the shallow, when you want to go for the deep, this is the beauty of soil mechanics. The top layer consists of varieties of natural material, including the parent rock and weathering rock products. The size of these weather rocks products vary widely. Not all of them are considerable as soils. The larger ones include boulders, cobbles, and pebbles, and generally considered as a fragment rocks. So you can see this. In one word, you are calling as a soil. Now I'm telling you should not call as a soil. It should be very specific. I am sure now who are going to attend this class, they will be perfect in the soil mechanics. They can identify the soil very confidently, and they can tell like how by seeing their appearance, you can tell this is sandy soil, silt, clay, loam. You can tell very confident. So you need little bit practice. So I will be helping you to understand all this mechanism. Then the physical and engineering properties of soils are primarily governed by the nature of the parent rock, the process of disintegration of rock, and subsequent accumulation of the particle, the climatic condition of the region. So, as I already told you, this is the as I already told you, the types of rock. Why I should read the and understand the rock. If you want to become an expert in soil, always you should understand their parent material. Who is that parent? Is a rock. When you are discussing about the rock, rocks are commonly divided into following categories, like igneous, metaphonic, sedimentary. See, this is the igneous. When because of the weathering and erosion, this will be becoming sediment, then compacting and cementation, it will become sedimentary rock. From here, what will happen? Because of the heat and pressure, again it will become metaphonic. Again, from it will become a melting, then it will become magma. Then when it cool, it becomes igneous. Same thing. That is the beauty. See, this is called cycle. How? Again, if it melt, heat and pressure, again it will become metaphonic, and because of this weathering and erosion, become sediment, then it will. See, this is the rock cycle. And what is dune and igneous rock? So igneous rocks are formed by cooling and hardening of molten magma. See, you can see this is the type of rock. Because of this cooling time, it takes thousands of years. the texture small to medium. The cooling time excuse you, it will take seconds to months, and this texture is invisible, microscopic line. So this is called igneous rock. So you have a different types of igneous: ballast, gabbro, granite, pegmatite, tuff, pumice. You can see ballast and granite. This is the common we used to discuss. So again, if you want to become expert in that, so we always study on the rock. That is separate, specialized. That is called geology. And coming to the sedimentary rocks, these are formed by the disintegration of other rocks like igneous or metaform or sediment. How this it will be, where it will be, the disintegrated fragment is known as a sediment. It is carried out by the streams and river and are deposited in the lakes, ocean and other water bodies. Sediment thus deposited or transformed into the sedimentary rock by the following process: compaction due to the weight of overlying material, cementation of the sediment by the chemical precipitation of the minerals, recrystallization of the sediment, forming a long chain of interlocked crystal, which turns the sediment into solid rock. See, this is weathering, how this is transported, this is deposited, this is cementation, this is the making of sedimentary rock. And this is metaphonic rock. Metaphonic rocks are formed by physical or chemical alteration of existing igneous or sedimentary rock. The principal agency of such transformations are heat and pressure, which turns the parent rock into denser state. Metaphonic rocks are generally less susceptible to erosion. Some common metaphonic rocks are genesis converted into granite, ballast, quartz is nothing but compressed sandstone, and marble, that is compressed limestone. See, this is the rock cycle, which I already showed you in the starting, same thing. See, this because of this weathering and erosion transported, see here it is going and depositing sedimentation. And when it compacted and cementation, this it becomes sedimentary rock. At inside it is a high temperature will be there, burning, urine and high temperature and pressure. Again it will become metaphonic. Again it will become melting, magma and intrusion. See, this is the nature of rock cycle. So with increasing the temperature, as the temperature increases, what will happen? The different types of material will be coming up. See, with increasing the pressure, if you go and see, this is the nature. With increasing the pressure and temperature, what will happen? You will get a different types of material like this. With increasing in the temperature, you will become a shale, slate, sheet, genesis, migmahate. With increasing in pressure, what will happen? Low graded. With increasing in metaphonic grade. See, the color, texture, everything will depend on the temperature and the pressure. So weathering of rock, the process of disintegration of rock into smaller fragment is called weathering. See, that's why I told you physical weathering, chemical weathering, and biological. Physical weathering, the major factor of physical weathering of rocks are extreme temperature changes, stress readjustment due to geological reason, heavy rain, and so on. The chemical weathering, is rock materials often react with chemical compounds carried out on rainwater, thus producing iron oxide, sulfates, and carbonates. See, you can see chemical weathering. When it starts reacting, what will happen? See, reaction with water, this is reaction with acid, reaction with organism, reaction with oxygen. See, that's why the shapes, texture, everything, how it is coming. Because this of physical, chemical weathering, it's all happening internally. See, now you can see how the color, shapes, everything is coming. Here you can see. It's all derivation of rock only. Why it is happening? Because of the process of weathering, the formation of rock fragment and the subsequent deposition of the resulting sediment forming a soil deposit take place a long time, even millions of years. The properties of soil thus formed are primarily governed by the parent rock category. For example, if I want to tell rock containing certain minerals with high silica content generally led to the formation of gravels or sand. See, you can see this gravel, this is sand, because it is led to formation of sand. On other hand, the ballastic rock having high percentage of aluminum, calcium, or iron generally produce fine grains of clay. See, that is the beauty. Why soil is taking water? Some soil won't take water. The reason is behind this all weathering. So if we want to understand that mineralogy, that is in a different concept, we will be understanding in the coming slides. See, now what happened? We have understood the origin of the soil. Now in module 2, we are going to understand in detail. Pure, see, in first module, we have understood the history, everything. But in coming to the second module, we are trying to understand the complete soil mechanics, like phase diagram, derivations, basic definition, everything. See, soil, I already told, soil is a three-phase diagram. See, this is a blue color water, air, this light color is, this is air, this is water. See, if you see below the ground level, it will be like this. To understand what we used to do, these two try to make it in a two-phase diagram or three-phase diagram. Three-phase means soil, water, and air. In two-phase means it may be a soil and water or soil and air. If it is soil and air, then it will be a dry condition. If soil and water, it is a wet condition. See, this is a phase diagram. To tell that exact number, percentage, weight, so we are expressing in the volume of volume. See, you can see this is volume of voids, volume of air, volume of water, volume of soil, and here also you are doing as a weight related. Weight of air, weight of water. Weight of air will be always zero, you know that. So this is weight of solid. You will be doing. So this you will be trying to develop the equations like this. And if it is in a dry condition, this is the two-phase diagram. If it is in a wet condition, see now it is in a completely water is coming. In previously, it was not there. It is in a completely fill of air. Air plus soil. Air, water plus soil. You are expressing in volume as well as weight. Now what you will do after understanding this? You want to check the density. So what you will do? You will do the field testing. What is the field testing you are going to do? Core cutter method as well as sand replacement method. This is the sand replacement method. You can see this is the plate where you are going to do that. This is the cone, approximately 0.02 mm volume. This is the handle, sand will be filled and this shutter will be open. This is the shutter will be open. This capacity is 3-liter cylinder. This is metal tray. First you will dig it. I will be showing the procedure. See, this is the sand you are taking. You will be sieving 1 mm, passing and retaining 600 mm micron you are taking. You are calculating the volume. This is the formula of volume. Then you will be weighing. If it is weighing, it is called as a W1. See, this is W2 when you keep it here. This two, W1 minus W2 will be the W3. How much soil you have taken in this box? You will come to know. Then you are going to field. Then you will be conducting this. You are going to the field. You will excavate the pit. You will put the tray. You will put the sand replacement core. You will open the lid. Soil will be collected. That is your how much soil it is collected. That is weight and volume of this hole. That is this. So based on this, you will get the bulk density of coarse grained soil. See, this is the thing. Mass by volume, weight by volume. You are calculating. So this is the bulk density of the soil you will be getting from the field. And also you are calculating how after bringing that soil, you will be calculating the water content by oven drying method or pycnometer method, sand bath method, rapid moisture method. See, this is the various methods. So what we will do in third module? In third module, after understanding this phase diagram, in first module, you have understood the who is the parent of the soil, how the soil is formed, everything you have understood. Now, with the background of module 1 and module 2, now you are trying to classify. Now you are very particularly you are telling. Now onwards, you won't be using soil work. You will be telling very categorically that this is sand, this is clay, this is silt. For that, how you will do? You will be conducting sieve analysis test. See, you will be taking different types of sieve. When you sieve for a 15-20 minutes, see, this is the particle retained. See, this is the coarser compared to this is finer. When you compare this is finer, again it is lesser. From top, it will be coarser. When you go deeper and deeper depth, it will become finer. So based on that, you can tell that now type of soil. See, this is called siever machine. You have a 7 set of sieves. You will be taking about 500 grams of soil. You are filling and then you are putting in this sieving machine for a 15 minutes. After 15-20 minutes, when you see, when you open, because of this dynamic vibration, the particle will be passing from the top sieve to lower sieve, which is retained on the each sieve. Then it will be measured. Then you will be calculating the thing. See, when you calculate it, it will be like this. When you will plot this, if it is in a poorly graded, see, it will be like point to point. It will be connected. Well graded, you can see all type of lower material to higher material completely. It is jam packed. Gap means 1 or 2 of the same sizes will be there. Rest is missing. Dear students, now this is a challenging for you. If you want to suggest this material for the construction, the design engineer should have knowledge about the classification And based on that, you will recommend the type of material for the construction. Suppose you are constructing the foundation. You want to use some soil material. You don't know what type of material, whether it is in a poorly graded, well graded, grab graded, whatever the thing. How you will recommend use this soil for the foundation, so the strength will be developed. How? For that, you have to do the field test. Try to understand. See, it is in a curve. If I want to classify complete, when you are talking about the soil, it is a mixture of all clay, silt, sand, gravel. To understand better what I did experiment on all the taking the complete soil, and I did and try to bifurcate. In gravel only, I made a 3 classification: coarse, medium, fine, and sand also coarse, medium, fine, silt coarse, medium, and fine, clay single. See, when you plot it, you can see this how nicely all type of materials are present. Like this is called well graded. Clay, gravel with sand, everything is present. Here, if you see only sand, silt percentage, and clay. Here, if you see only medium sand is present. If you see only fine sand is present. If you see only gravel is present. So, my dear students, here your knowledge plays a vital role. You should be very specific. You should be able to understand type of material you are going to recommend. So that you will be understanding by doing this experiment. See now what you will do with the fine grained soil. The fine grained soil is nothing but silt and clay. You want to understand how much water it can take, when it will be behaving differently, sticky, plastic, all. How? For to understand what you will do Atterberg limit. That Atterberg is nothing but the scientist professor name who has developed this equipment. Okay, you can see liquid, plastic, semi-solid, and solid. So you will be doing, this is the plastic liquid limit determined by the Fasaganda device. First, you will be preparing the soil, and you will be pasting in this, and you will be cutting like this, and you will be applying the number of blows. It should be less than 25. If it is reaching less than, then you will be noted. If it is more than 25, then you will discard and you will repeat the experiment. Based on that, you will try to understand. See, it is difficult to adjust the moisture content in the soil to match the required 12.5 mm closer to glue. I already told this is the soil sample. You did it, prepare the paste, then you cut it to the groove, and you repeat it at least 3 times. You have to repeat. You can see 1, 2, 3, 4. It means that 4 trials we have did, and we have taken the number of blows with respect to 25. Then you will tell that 42% of water is present. Next, to check the plasticity, what you will do, you will make it in the round form, and you will be making the needle of 3 mm. If soil can be rolled into 3 mm dia, but crack developed on the surface of the sample, it is silt or silt with clay. If soil cannot be rolled into thread of 3 mm, then it is a non-plastic. So here it clearly tells who is plastic, which soil is not plastic. It can be easily identified. And also this plasticity index indicates the degree of plasticity of soil. See, this is the thing. Plasticity index you will be calculating by liquid limit minus plastic limit. And we have the chart given by the Burmester 1947. It says like, if plasticity index 0 comes, then it is non-plastic. If it is 1 to 5, slightly plastic. 5 to 10, it will low plastic. 10 to 20, medium plasticity. 20 to 40, high plastic. If its value is coming more than 40, it's a very high plasticity. So this will help designer to understand the nature of the soil. And also sinkage limit defines the water content at which soil changes from semi-solid to solid state. So this test you will be doing in the laboratory. You will identify the sinkage limit. After doing all the tests, what you will do, you will plot it, plasticity index versus liquid limit. See this portion, this is a line. This portion is called inorganic silt of high compressible and organic clay. And this is inorganic clay of high plasticity. And this portion we have, it's an inorganic clay of medium plasticity. It's an inorganic clay of low plasticity. As we go far away, which I already told, more than 40, it is a high plastic. If it is less, it will be low plastic. It will come to Fine-grained soil can exhibit one of the four states: solid, semi-solid, plastic, liquid. Water is the agent that is responsible for changing the state of soils. The soil gets weaker if water content increases. The three limits are defined based on the water content that causes a change of state. The plasticity index defines the range of water content for the water which soil behave like a plastic material. And also liquid limit gives the measure of the strength. The soil strength is lowest at the liquid state and highest at the solid state. My dear students and participants, in this diploma course, I will be introducing, for making you more benefit, you may get lot of literatures on the laboratory, but now I'm trying to make you to get the feel of this subject. So I'm introducing this topic called field identification. Suppose now you're going for the site. There you found some materials and your engineer is asking, what type of material this? You have to tell immediately. So for that, what you want to do, you must have some knowledge. You can see different types of soils are sitting on the different boxes. This is gravel, sand, so many things. So what to do in that case? You should be very fast. So for that, you have to identify. Identification of soil in the field is limited to defining the color, texture, and plasticity, done without benefit of major equipment. It is necessary to do the general assessment of the sites during the field reconnaissance survey and during the initial phase of work. Sometimes this test may be sufficient for ordinary work, but in some cases it will be severe as an acid. Head. The detailed and precise identification requires laboratory testing. Visual examination is nothing but texture. By looking the soil, we can make a distinction between the gravel, sand, and fine. However, silt and clay particle cannot be separated without further magnification. The examination is done by driving a sample, spreading it on flat surface, and then simply segregate into the various components. The shaking and dialtency. I told you, once you go to the field, you should understand the soil sample. How you will do? Take the soil sample, put some moisture in your hand, try to compress it. You can see this, whether it is coming a shining color, whether it is a squeezing, whether it is sticky, it will tell, every step will tell the nature of the soil immediately. Soil is moisture to putty state and pat is formed or placed on the palm hand. So You are making like, and you are putting on the palm hand, and this hand is shaken vigorously, and between this stick and, if the surface become glossy like this, shining by rinsing the moisture to the surface on squeezing between the finger, it disappears, glossy disappear quickly, it is sealed. It means that when you shake it very fast, initially it look like a shining, after a few seconds it will disappear if it is sealed. If the process appearance and disappearance of moisture slowly, then it is called silty clay. When reaction doesn't occur, the soil is, then if it is called clay. See, this is clay material. This is the silt. How to check the plasticity, toughness? Take the soil sample and allow it completely in the dry. Attempt to made it to break it between the thumb of the finger. Hold it and break. If doesn't break, it means that high plastic clay. If it break with a great effort, it is a plastic clay. If it is can be broken and powdered with easy, then it is silt or silt with clay. If it is crumbling or powdering will occur while being picked up, then it is silty sand. So these are the few tests you should be always keep in the mind. So whenever you go for the field, you can able to identify. So that will be giving you more confidence for it. And also wet test. Please place the pint of soil on the palm, add a little water and rub it. See, you are rubbing it between the thumb of the finger. If soil gives soapy touch and sticky to finger, then it is a clay. If doesn't give soapy touch and doesn't stick to the finger, then it is in a silt, dries quickly silt. If it is give a rough feeling and no sign of wetting appearance, it is called fine sand. Soaking test. Here also put some small lumps of soil in glass container containing the pure water. Observe the lumps disintegrate water. If soaking and disintegrate take place very quickly, it is silt or clay of low plasticity. If soaking and disintegrate take place very low, it is clay of high plasticity. See, that's why I told. And also you can check it. Sand, gravel, there will be no cohesion. If it is sandy soil, then you make this little cohesion. So that's why you can make the little cone. If silty soil is there, you can make the cone, it will have a good cohesion. If clay, then it will become a perfect. See, this is all small trick you have to use in the field, so you will understand more. That is the beauty of the this diploma course. We are giving the small ideas, so you will be always connected with the field as well as classroom. Now coming to the compaction. Why you want to do compaction? It increases the bearing capacity, increases the durability. See, initially without compaction, it will be like this. Once you do compaction, it will become like this. Poor compaction, especially in the drainage, when you are making piping, what will happen when you do proper compaction? High resistance or to deformation, high resistance to force the damage. And also, objective of compaction is increase the shear strength, reduce the permeability, reduce the compressibility, control the swelling and shrinking, reduce the liquefaction potential. Okay. See, this is the standard Proctor test we are using. See, the diameter is 114 mm, collar internal is 101, height is 305, hammer height. This is a 5 kg hammer. This is the mold you will be using. How you will do? You are taking some 3 to 4 kg soil. You will be making proper mixing and you will be putting in 3 layers in this mold and each time you will be blowing 25. That hammer weight is 2.5 kg hammer. See, before compacting, soil will be like this. After compacting, it will. How you should compact? It should be like 1 blow, 2 blow, 3 blow, 4. It means it should be completely circle. When you make proper successive blows, see, then soil will become completely. Before compacted, it will be like this. Voids are there. When you make proper compaction like this, see, now voids are completely filled. Particles are rearranged. You are removing the air voids. Then what you will do? How to measure the density? You are taking water content on the x-axis in the percentage and density in y-axis. Then you are plotting. See, this is the maximum dry density. This is the optimum moisture content. And this is the zero air void. The saturation is 100%. But the curve represents it is in a fully saturated condition. S equals 100%. But it can't be reached by compaction. In field, you can't do that. Maximum 95%, 98. That's it. But in laboratory, we used to tell 100%. Theoretically, unit weight is given by gamma d into unit weight into specific gravity divided by water content into specific gravity. This is the formula. Why we want to do modify Proctor? We were happy with 2.5 kg hammer. Why we want to do? Because aircraft and this, the load will be very high. This all dynamic loading. So geotechnical engineer should know when flight is landing on the soil, it should not settle. It should able to take the strength, that load. So there, to understand what we will do, we will be doing this high energy hammer. Same thing, instead of 3, we are increasing 5 layers. See, this is the hammer. We are blowing 10 blows. See, this is the normal standard compaction, small one. Once you do with a modified, with a larger diameter mold, high energy hammer, the energy has been increased drastically. Optimum moisture content reduces. Here also density value increases. Now coming to the permeability, this is the two types, constant head and falling head equipment. Permeability is always depends on the Darcy's law, and this is measurement. See, this is the soil. Okay, once you leave the water, it will travel like this. It will be coming. How fast it is coming, how slow it is coming, that you will be decided. Soil consisting of solid particles with interconnected voids where water can flow from one point of high energy to a point of low energy. Okay, you can see this. Each soil will have if it is in a gravel, sand, silt, clay, you can see how the soil can flow into that. What is permeability? Permeability is the measure of soil's ability to permit water to flow through the pores or voids. If it is loose soil, easy to flow, high permeability, and if it is in a soil is very dense, completely packed, then water going and coming, it will take long time. So that's why we define as a low permeability. If it is coming very fast, it is called as a high permeability. So importance of permeability, the following application where you will be using this parameter. Design of earthen dams is very much based upon permeability of soil. The stability of slopes and retaining structure can be greatly affected by the permeability of soil. Filters made of soils are designed based upon the permeability. And importance of permeability. So you can estimate the quantity of underground seepage, what is happening, you can able to estimate. And also you can solve the problems involving pumping, seepage, water from construction excavation. So to understand all this, the permeability is the important parameter. See, this is the importance of permeability. This is the dam. See how that this is the free body, crust, filters. If you want to use suitable materials, you must know the type of material you are going to use. For that, you should do the permeability test and recommend it properly. Without understanding the, you can't do the design these filters. Why does water flows? It flows from A to B. The energy is higher at A. When it is going B, it becomes lower. Energy is dissipated in overcoming the soil, the resistance, and it is head loss. I already told this is Bernoulli's equation will say like this is the dam upstream and downstream. The energy fluid, the potential due to elevation, this height with respect to the pressure due to and the kinetic energy due to velocity. Then at any point in the fluid, the total energy is equal to potential energy plus pressure energy plus kinetic energy. So this is the way you will be calculating the total head. And this is the at different points. If you have a two different head loss, then we will be using this equation, head loss, non-dimensional. This is called hydraulic gradient, I, delta H by L. This is the difference of total head divided by distance between A and B. Okay, this is A point, and this is, if you want to check the difference, how much loss, then you will be applying this one. Tricky case, remember always look at the total head. So always it's a very challenging and hydraulic gradient. In the field, the gradient of head is the head, the difference over the distance separating the two wells. Okay? You can see this how from A to B it is difference is going on, total head impermanence. So that's why basis laws will apply. The velocity is proportional to hydraulic gradient. At zone 1, it will be a laminar flow. In zone 2, it become a transition. In zone 3, it will become a turbulent. This is the Darcy's law, V equals K into I. Discharge velocity of the flow can be considered. So this is the velocity. So to determine what we wish to do, we do the in constant rate and falling rate and pump well test also. See, this is the formulas. This is the constant rate. Generally, constant head will be primarily used for the coarse grained soil, and this test is based on the assumption of laminar flows. This is law. Q equals K into I. This is the soil sample. This is the constant head, water you're filling. It will be coming out. You're measuring with the time. Then you will be checking. See, you're measuring how much it is coming. This is the component of constant head. So this is the, when you are putting, you will be having a different filter paper, soil sample, filter paper, porous stone. This is the spring. This is the jar, beaker, constant and tag. This is the mold. Similarly, falling rate means there will be no head. It will be having the variation, T1 and T2, H1 and H2. This will be used for the fine grained soil. See, this is the formula. See, this is I told. See, this is the derivations of the formula. We will be discussing in later. See, if it is in a different layers, it will be going. If it is in a stratified soils, then it will be like this. But limitation of laboratory test is generally hard to duplicate in situ soil. The structure of in situ soil may be disturbed because of sampling and testing preparation. The small size of laboratory sample leads to affect the boundary condition. Yes. So always field test will be best. Borehole test, packet test, pump well test. Okay, this is the pump well test we are doing. There you will be fixing and you are checking the aquifers. Now is consolidation. See, consolidation, here the odometer test is used to investigate the one-dimensional consolidation behavior of fine-grained soil. See, this will be done for only for the sand and clay. Place the same size of the ring, apply the load. See, this is the applying the load. Measure the height changes when you are applying. Repeat the new load till it. See, this is undisturbed sample of 25 mm in the height and 75 mm in the diameter in the steel confining ring and immersed in the water bath. Okay. Then several increment of vertical stress are applied usually by doubling the previous increment. Then what you will do? The two-way drainage is permitted through the porous disc at the top and bottom. Then the vertical compression of the soil sample is recorded usually highly accurate by the dial gauge. When the soil is compressing, you will be keep on noting the dial gauge reading. And each increment, the final settlement of soil sample as well as the time taken to reach the final is recorded. So when you are doing, you will have some assumption like load distribution uniform, stress distribution the same, no lateral deformation, the area of sample section is unchangeable, solid state is uncompressible. After doing this testing, you can able to determine the height of the solids, change in the height, final specimen height, height of the voids, final void ratio. This all will help and we will be plotting the graph like void ratio versus effective stress. So this is the virgin curve. Effective stress versus void ratio you are doing. And also you will try to identify this is initial settlement, initial compression. Mostly caused by the preloading. When you apply the load, then initial will happen. And this is called primary consolidation. This will be happening because of excess pore water pressure. Gradually transferred to the effective stress by expulsion of pore water pressure. And third one is secondary consolidation. This will occur completely dissipation of excess pore water pressure by plastic adjustment of soil fabrics. And this is the compression index CC value you will be calculating and swelling index CS. And coefficient of compressibility of coefficient AB also you are calculating. So low compressibility, it should be 0.1 less than AB, less than 0.5 MPe. Middle compressibility is greater 0.5, highly compressible. And volume, coefficient of volume compressibility is denoted by MB. Now coming to the main thing is shear strength. You're checking the strength of the soil. So here, how you will be doing? You will be doing with various tests like a direct shear. So this is the porous plate, soil. This is shear box. First, you are pouring the sand specimen here. Then leveling, preparation of sand specimen. Then you are applying the pressure plate on this. Then this is the soil sample. This is the porous plate. This is this pressure plate, steel ball you are putting, and this is the proving ring. Then you are applying the direct in the horizontal. See, this is the horizontal direction. You are applying a vertical load to the specimen and wait for the consolidation. Lower box is subjected to horizontal displacement at the constant rate. See, this is the shear box, dial gauge you are applying, and proving ring, dial gauges to the measurement of horizontal. Loading frame to apply vertical load. How you will calculate this? See, it will be calculated by normal stress Normal force divided by area of cross-sectional of the sample, and shear stress, shear resistance developed at the sliding surface divided by area of cross-sectional of the sample. See, once if you do for a different types of soil, you can see shear displacement versus shear stress. This is the loose sand or normal consolidated clay. This is dense sand and over consolidated. And this is with respect to volumetric change in height of the sample. So this is for the dense, this is for the loose. Compression will go below and this will be expansion. From this sample, you will get a, generally this will be done for the sand. The cohesion will be 0. Here there will be no direct shear test drained, pore water pressures are dissipated. So it will be 0. Therefore, C will be 0 here. And similarly, for the traction, this is the soil sample, this is the water, this is the cell pressure, back pressure, pore water pressure, this is O-ring, this is piston. You are applying, see, this is sampling tube, undisturbed sample you have collected. And you are cutting the sample carefully, trimming, and you are preparing the sample 38 by 70 sheets. Then your sample is covered by this rubber membrane. See, now you can see this. You are applying a vertical load by proving ring. This is piston. This is the proving ring. Dial gauges are there. Here you have 6 components should apparatus are there. Axial loading piston, cell pressure, dial gauge measuring, vertical displacement, specimen membrane, pore pressure gauge, pore fluid. So you have a different types of test. Here you have a 3 types. UU, it means that unconsolidated undrained, consolidated drained CD, and CU, consolidated undrained. So based on the field condition, you will be testing. This is the vertical. This is sigma 3. Sigma C is nothing but confining pressure. We used to call sigma 3 also. And this is called delta V equals Q. This is called deviatoric stress. So I told you, CU test, consolidated, unconsolidated sample. This it will be first you will be sampling. You will be keeping the soil completely in water, make this saturated. When doing the test, you will there will be no wall will be open. Then it will be unconsolidated. When it is drainage, here wall will be open. Then it will be drainage. When there is no wall, then it will be no drainage. See, this is the soil specimen. This is the pore pressure. Wall. This is the cell pressure. You are checking the confining pressure sigma 3. This is the piston. You are applying a vertical load directly, and you are measuring the dial gauge measurement. This is phase 1. Water is filled in this cell, which creates the cell pressure. Sigma 3 is shown in the figure. See, this is called water pressure completely. In phase 2, what you will do? You are shearing. We gradually increase the pressure at the piston here until the sample failed. Till its soil should take sufficient strength. Till it failed, it will be keep on applying the pressure. That is called shearing. See, UU test, unconsolidated, undrained, maximum stress. So you can see axial strain. If you see different confining pressure, you are getting the more circle for the sand. And unconfined compression strength. This is UCC test. There will be no sigma 3. It will be 0. Only directly you are applying a deviatoric stress. That's why it is starting from 0, and this is a normal. This is unconfined. There, the confining pressure is 0. Dear students, with this knowledge, you will be doing very important project with respect to practical identifying the field problems, and I will be helping you in this to get a to define a good objective of your thesis, so you can complete it successfully, and this thesis will be helpful for your future also. From this thesis, you can able to publish some good publications. You can do patents, copyrights, anything. Thank you. And for more information to know about me, you can go through this website. You can see a lot of literatures, journal papers, my videos are available on soil mechanics, foundation engineering, waste management, so many things. And you can contact me anytime on this mobile number. My email ID is there. Thank you.